Welcome to Simplilearn. We are honored to have you join us today for the future of big data with your host, Syed. My name is Richard, and after this intro, I'll be mostly in the background helping Syed so that everything moves smoothly. The future of big data. As the information technologies world explodes, the opportunities and growth in big data field explode with it. There is more information generated already this year than the sum of all previous years. Sorting it all out, making sense of it, is big data, and having a clue to the future of big data helps to open up career and professional opportunities. If you do not know Syed, Syed is a big data and Hadoop consultant working with best-in-town analytics, Edureka, and Simplilearn, a Hadoop expert with a background as a senior software engineer and project lead. He carries certifications and expertise in Apache Hadoop, the Data Scientist Toolbox, MongoDB, getting and cleaning data, R, programming, PMP, and exploratory data analysis. For the last half a decade, basically everything big data. I'm excited to have Syed here today. For those who aren't familiar with this form of webinar, I want to introduce you to your dashboard or control panel. If everyone could locate your dashboard and then locate the question module. Go ahead and message hello in the question module. Just say hi to Syed. Let us know you're excited to be here. This also lets us know that you're hearing us and everything is connected correctly. Great. I got, oops. Melanie, great to have you. Shukla, I hope I'm saying that right. Hello. Yes, you won't be able to hear me because you're going to be on mute, so you want to use the question bar. Great to have you, Sabranzit. I hope I'm saying that correctly also. Great to have everybody aboard. If you have like a specific question on your career or real world journey, post it in here in the question module. This question module is your best friend. At the end of the presentation, we'll have a 15-minute Q&A, and that time we'll try to cover all the questions that are asked in the module. Some of them might be covered during the session, but generally we try to answer them at the end. You didn't come here to listen to me speak. I'm proud to introduce Syed, who will be your host for the future of big data. Go ahead and sit back, relax, have a cup of coffee, tea, or if it's in the evening where you're at, maybe a glass of Merlot, and enjoy. It's an honor for me to hand this over to Syed. Thank you and happy learning. Syed?
Yep, Richard, how are you doing?
I'm doing excellent today. How are you doing?
I'm doing fantastic. Thank you so much for asking. There's this one thing, Richard, I cannot see questions coming up on my window, in my question window. So do you or Rakesh, somebody want to check it? I'm not able to see any questions from any of the participants.
Let me just go ahead. They should come up. I have you down as presenter. Everything looks right on my side. Let me go ahead and
I can see it now.
Okay, excellent. I'm going to go ahead and mute myself and let you take over.
All right, excellent. Thank you so much, Richard. Once again, welcome all of you all. Hopefully, you guys are able to hear my voice and see my screen. Once again, thank you so much, Richard, for giving that wonderful presentation about myself. Somebody's asking me what the webinar exactly going to be. This webinar is about a little bit about big data technologies. Now that we've past the majority of this year 2016, the future as it is going to be for next couple of years. So that is what the webinar is all about. Hi all of you all. Let me just come out of this screen and introduce you to my cheat sheet. So any one of you who have been like attending my presentation, you would know that my presentations or my batches or my classes would know that I usually use this kind of cheat sheet wherein I list down all the topics, keep typing it over here and keep explaining the concepts, keep on toggling between this little window over here and this sheet, and then carry on with the presentation. I keep completing topics and I keep coming back to this sheet and keep marking it as done like that, as my introduction has been done wonderfully well by Richard just now. Amazing. So that's where we are. Without any further ado, let me just get started with the presentation. So before I really tell you guys about the future of big data, let me just, for the benefit of all, let me just introduce you to what is big data, introduction to big data as a concept, and then carry on from there. So I'm sure you must have definitely heard about big data as a concept, as a technology, as data. Definitely amongst your friends in your organization, the interviews that you would have been giving, and things like that. So what is big data? The other day I was giving this presentation in one of the virtual online sessions, and one of the participants asked me, is it about size? It is about volume? Is it about speed? Is it about accuracy? What is it about? And what I told him is that, and where does the game begin, and how big is big data? So what I told him is that, what do you usually work on? Do you work on a laptop? He said, yeah, laptop, desktops. So I asked him, how much is the size of the hard disk, that your laptop or a desktop has? He said a terabyte of disk, hard disk, or 2 terabytes of disk as far as laptop is concerned, or 4 terabytes of disk as far as my desktop is concerned. I said, amazing. Uh, the size of data that your computer cannot hold, it's beyond the capability of your individual computer to hold that data, to store that data. It is where the game begins. And by that token of logic, we can definitely say that somewhere around 5 terabytes of data is where the game begins, which is where saving it on your individual machine becomes a really really big challenge. Really big challenge. And guys, as Richard said, and towards the end of the presentation, we'll have 15 minutes of a question answer session. So just if you have questions in mind, I know that you guys would have enough and plenty of it. So just hold back. Let me just go through the content, and then at the end of it, you guys can go ahead and ask your questions. And mind you, me and Richard don't leave any questions that you post, and you might queries that you might really be having. So there you go. On the concept part. Back to the content of the presentation, and as I was talking about big data. So yeah. So any data which your individual computer cannot hold, right? And let's talk about the best case desktop. Right, 4 terabytes of disk, 5 terabytes. Is really, we can safely say that this is where your game begins, isn't it? If this is where the game begins, that means the very first thing that this big data, very first challenge that this big data imposes or throws in front of you is that it's about the storage, right? Let me just show it to you, kind of, just list it down over you, in front of you over here. Storage, right? How do you store it? If your individual computer cannot save it, then how would you store it, right? So storage is a big problem, and it's a problem which is nice to have, because if you can store this data properly, and as you will see, as I'm going to kind of tell you that more and more organizations have started considering data as something which is an asset, just like any other physical or soft asset that your organizations might have. You know that this is an asset. You know that if you can store it well, you can definitely make use of it. So storage is a big challenge, first of all. Secondly, if you're able to store it properly, the second challenge that you come across is how you process it, because that is your ultimate aim, isn't it? If you can process this data in a meaningful way, get some crazy insights, get some amazing insights out of it, you can basically make some decisions. You and your organization can make some really interesting decisions, some really if I may call it game-changing decisions, as far as their business or as far as their competition is concerned. So storage is a challenge, and then if at all you're able to store it properly and nicely, then processing is another challenge, right? So big data, as as we are coming to understand it, because of its sheer size, the sheer humongous size of it, storage is a problem, and then processing on top of it is again a bigger problem. There are other aspects to big data. Sometimes you will feel that the data is coming at a very fast speed, as I'm going to be telling you in one of my points, that in future you will see that this speed will become faster and faster. As the volume would grow, the speed also will become faster and faster in next upcoming years, and that is where a lot of opportunity lie for professional like you are. So anyways, more on that a little later. Storage and processing, that's what the business is anyways, right? So let's go ahead and understand what are the technologies which help you take care of these two nice to have challenges. Well, you would have heard about this technology, Hadoop, and its associated ecosystem. That is what provides the solution for these two big challenges, right? Storage and processing, right? So Apache Hadoop, it's an open source software from the Apache community. It is the software which basically provides the solution for these two challenges. Let's go ahead and find out how does it provide the solution to these two challenges that I've just now mentioned to you guys in front of you. Let's understand Apache Hadoop in detail, a little bit detail, and in the regards of these two challenges that I've mentioned to you, just now. Amazing, very good. So that's what we are. That's where we are. The definition is written over here, right in front of you. Let me just arrange my screen a little bit so that I can get a little bit of real estate to see how we are doing and show the screen properly to you. Apache Spark, let me just push it a little below so that you don't get distracted. Amazing, that's where you are. Apache Hadoop is an open source framework, right? It's an open source framework. What do you mean by open source? Open source is a software which has certain characteristics, isn't it? It's free of cost, open for the community to play around with it. There are no licensing connotations to it. You can kind of just pick it and start using it. And there's also a very huge community support for it. There's a very huge community base which supports it, right? So it's an open source framework. What is a framework? Let me keep on emboldening these important words in this definition as we move on, right? To make it really interesting. It's an open source framework. What is a framework? What is a framework? A framework is those pre-developed, pre-processed, pre-tested libraries which basically are provided to you off the shelf so that you can use it in your program. And what is the functionality that these pre-tested, pre-developed libraries encompass? They have in themselves. These functionalities are those repetitive, mundane, administrative work that you would code that you would always want to write in your in your program, and you will see yourself keep on repeating it all the time. Right? I'll give you a couple of examples to make it simpler for you. Transactions, security, logging, right? These are the kind of things that you would always want to do in your programs. So framework is that kind of that kind of libraries which makes your life easier. Right. Now, if Apache Hadoop is an open source framework, let's go ahead and understand what does it provide. Right. What does it provide? What is it that it is providing to us? Right. So it is meant to provide an automated distributed computing environment. It is meant to provide us an automated distributed computing environment. Now, what is distributed computing environment? For those of you who would have worked in distributed computing environment, manually should I say, would know the pains and perils of distributed computing environment, right? 10 different machines, one of the machine going down, the other machine crashing, you having to make sure that you replace with the bad machine with the good machine, you making sure that the processing that was already done on the bad machine, the crash machine, is replaced by a good machine, and the processing starts from exactly the point where the processing stopped at the time when the machine crashed. Too much of a hassle, too much of a problem, too many things for you to handle on your own manually, wherein you are here in this environment where you want to do some analytics, where you want to do some analysis. You don't want to spend your time in thinking about all these administrative stuff, right? This has to be provided by some kind of framework. This has to be provided by some kind of open source framework. Isn't that make it even more attractive to you? That's exactly what Hadoop framework does for us. It is an open source framework which provides the automated distributed computing environment to us. It says that if you have got ample amount of resources available in your cluster, I'm going to make sure that if one of your machine crashes, I'm going to replace the bad machine with the good machine. I'm going to make sure that whenever the good machine is available, I'm going to start the processing exactly from the point where it stopped when the machine crashed. And then lots and lots of other facilities, lots and lots of other services, lots and lots of other administrative, mundane and repetitive services, so that you as a developer, you as a business analyst can concentrate only on exactly why you're here for. You are here for to do your business analytics, right? And that's exactly what you concentrate upon. Exactly. Amazing. Excellent. We got we got a bit of idea about it. Then just 1 second, I'm just going a little bit down. So this is what it is. How does it provide the solution to the above two big data challenges? How does Hadoop provide the solution to the above two big data challenges? It provides something called as HDFS, Hadoop Distributed File System, which basically stores big data for you, and then it provides a framework called as MapReduce, which basically helps you process that data. Right? HDFS is something which is based on a white paper by Google called as GFS, Google File System, and MapReduce is based on another white paper by Google called as MapReduce algorithm. Right. So two problems, in front of you, with two challenges in front of you, with big data, imposed in front of you, and those two problems got solved by big data as a concept, by Hadoop as a framework. Excellent. So brief background on what the framework looks like. Let's just go back and let's just go back to the list of things, list of the content, and see what all things we have completed. Introduction is fine. Introduction to big data is fine. Challenges with this big data is fine. Available solution Hadoop is fine. I'll quickly, before moving on to the points on future of big data, I'll just quickly run a Hadoop program and show you how the program looks like. For you to get an idea about how the technology is. This is how this is how you kind of interact with the software. And let's say I want to run a job over here. So I can run a job like this. I can basically package my program in some kind of jar file. I have some kind of input file. I've got some kind of output file. I'll just go ahead and enter this program, start get job running, and bingo, there you are. You have a MapReduce and Hadoop job running on big data. So bit of a background as far as the technology is concerned. Let the job run. It will take some time for it to complete. While the job is running and while it is getting completed, let's quickly move on to the points of the presentation in terms of technology is fine. We know that big data has opportunities with respect to it, but where is it going? What is the future? What are the there you are. The job got completed. So kind of just give you a bit of idea about what the technology looks like. Yeah, so sample run, there you are. I completed that as well. So future of big data, right? Quickly, I'm kind of just moving on to the topic, the main topic. As I was telling you, about the storage and the size and the volume of big data, what trend that you can expect in next couple of years would be the volumes is going to the volume is going to grow. It is going to get bigger and bigger. If you've been in big data and Hadoop and its related associated technology for some time, what you would have observed is that Hadoop started with version 1.x, where there's a concept called as block size over there, which HDFS uses to divide your big data file into different chunks. Now, when Hadoop 1.x started, at that time, when Hadoop 1.x, the latest version, initial version, the block sizes used to be at that time 64 MB, right? 64 MB of block size. Then, time moved on, industry matured, and then the data became bigger and bigger, huge and huge, and what people felt is that 64 MB of block size is too small for big data to for the software to handle, and that is where the default block size of HDFS increased. At this point of time, if you work in the latest version of Hadoop, you'll see that the block size is 128 MB, and very near in future you will see that this block size will increase even more, because the size of data is increasing, right? Hadoop is in version 2.x right now. If you really want to see what the version is, quickly you can come to the software and do something like this over here. Version There you are, Hadoop 2.7.2. Very soon you will see that you will have a Hadoop version major release 3.x, and that is where the block size is something that is going to increase because the data is increasing. The data is becoming huge. The data is becoming even more voluminous. So you need bigger block size so that HDFS can handle it properly. So that is one thing that you can expect. Huge data size and the block size increasing in that regard. Amazing. That's the first point. Second thing is the processing landscape is also changing. It's changing pretty big time. What people have started thinking is that MapReduce is something which is a framework of choice, which is a part of Hadoop as a preferred technology to process your big data. But MapReduce is something which is slow to process. If you have a little bit of background about what MapReduce as a technology is, you would know that MapReduce is divided into two parts: the map part and the reduce part. And then when the mapper runs, it throws an intermediate output on the machine in which the mapper program is running. And there are in the big data world, in a simple big data Hadoop job, you would see that there are tens and thousands of mappers running. Now, each one of these mappers dumping output on the individual machine on which the mapper is running. If that is what your mappers are doing, writing the data on the hard disk is something which is very, very performance inefficient. So there has been a need of a framework which basically can change these the processing of these jobs, and that is where these new age frameworks like Spark and Tej are coming up, which is like a highly optimized, performance efficient processing frameworks for big data. If you've also been reading a little bit about big data and its related technology, you would know about some of the commercial softwares of Hadoop, like Apache Hadoop, like Cloudera, for example, which is one of the industry leaders in giving the commercial or the professional versions of Hadoop, wherein they give you raw Hadoop and then some additional additional features on top of it, and you basically have to pay for it. And then they provide you service for a prolonged period of time, support and service for a period of time. Now these commercial providers like Cloudera, like Hortonworks, like MapR, if you go to their website, you will see that they've already replaced their processing part. Right? If they've already replaced the processing part with Spark. The processing part no more has Hadoop in it, no more has MapReduce in it, right? So it is the beginning already of the change that is supposed to come, right? So let me just get back to this slide. Right, so from MapReduce to Spark. So Spark is one technology which is already been like into big time into the big data processing world, and something which is expected to pick up even in a major way. So that is one technology that you might want to concentrate on. Faster tools will be available to process data like Apache Tej. If any one of you have installed one of the Hadoop ecosystem component like Hive or HBase, for example, you will see that when you install it now and you install it on top of MapReduce, you will see a message saying that migrate your Hive to a faster processing engine, either Apache Tej or Spark or anything else but MapReduce, because MapReduce is something which is going to phase off very soon, right? That is an indication enough, which means that you have to move to a faster framework, a faster processing engine, right? So that is another point to note. Faster tools will be available to do this, and that is where the skills will be needed in the industry. And that is where, if you upskill yourself in these technologies, you would be able to kind of make the best out of it. There are other frameworks also, like Kafka, for example. Kafka is an Apache tool which it does messaging, which provides messaging framework for big data. So if you have worked on messaging engines, you would know that your typical messaging engine like your RabbitMQ or your IBM MS MQ, it works on a pub sub model or publish subscribe model, but it basically passes data in a synchronous fashion where the data payload is small in size. Kafka is similar, but the data over here is bigger in size, right? And Kafka is another framework which is continuously being upgraded and being worked upon to kind of come up with faster and faster processing of data in asynchronous, faster and faster processing of big data in an asynchronous fashion. So that is one more area where the opportunity lies, and your skills might be useful. Real-time streaming data is also something which is going to be the future. So I keep doing a lot of consulting assignment. I was recently in Sydney where I was working with one of the organization which was basically into logistics, and they had huge machines which were carrying on and off loads of uh, uh, stuff from maybe from a shipyard to a truck, and then the truck would carry it on to some location to offload it. And these machines was something which was connected to computers, and these computers were continuously observing the way these machines work. And what they felt is that even if for a couple of hours these machines go down, they would incur heavy losses. So what they wanted to do was that they wanted to continuously monitor the while these machines are operating, while these machines are doing their work, if they can continuously analyze this data and preempt proactively what are the chances that these machines can fail in future, and how likely and when they are expected to fail in future. They can take some contingency measures well ahead in time, so that they have a stopgap arrangement available to them. So that is what is streaming data, where you continuously analyze the data, you continuously store the data, analyze it, and keep on looking for patterns, so that you can in case of any contingency, in case of any emergency, you can quickly take some stopgap measures. So real-time streaming data. Now, one of the frameworks will basically deals with real-time streaming data. You have got Flume, which is in the current Apache ecosystem framework, which is being extensively used as far as the streaming data is concerned in the industry right now. You have Spark has got a streaming library which you can use for this kind of streaming application. So that is another technologies. All said and done, streaming is another area where a lot of opportunity lies as far as big data in next couple of years is concerned. So there you are. As far as the job role are concerned, a lot of people keep on asking me all the time, has big data lost its sheen? Like, is this another fad? Are there really opportunities available? What are the kind of roles which are available in the industry? What I've seen the trend is that the organizations, since organizations are storing almost anything that they are generating out of their systems, they need people to manage it. They need people who can take responsibility in managing that data. So roles like chief data officer, chief information officer is something which is going to be upcoming, and that is where you could see that in next 3 to 4 years, those are the kind of roles which are going to be available, which are going to be coming up in abundance. More and more data analytics professionals will be required. That is one more trend that I'm observing with all the clients that I interact with. The industry would look forward to smooth the talent crunch. As I said, I keep going and interacting with global clients. I was recently in Sydney, recently in Europe as well. What I've seen is that these countries, these industries, these domains, they need a lot of professionals, but there's a dearth of professionals, well trained, knowledgeable, experienced professionals, because almost everybody wants to do something with respect to big data, something with respect to analytics, analysis of big data. So there's a dearth of huge dearth of resources, and which is where you working on these technologies which I've just now mentioned, Spark, Tej, Kafka, streaming in Spark is something that is going to be very very useful. So big data, much more big data analytics professional. When I say big data analytics professional, it covers everything. So data science, data scientists, Hadoop developers, people who can manage these projects, people who can architect and design these kind of projects is also something which is going to be needed. Data as a service model is also something that will be needed. I was recently reading a case study where I understood that organizations like Sun Institute in US, they collect the data and then they sell it to various health organizations. TFIR, for example, Tata Institute of Fundamental Research, is one of the clients for Sun Institute, which basically provides medical and health data, which these organizations buy it and then use it for their own research. So, something like cancer research, or research for Alzheimer's, or look out for patterns, DNA sampling, and those kind of things. So data being sold as a service is another trend that you can see upcoming in future. Algorithm as a service model is another wonderful thing that I have seen emerging. You would have definitely been knowing about these websites like Algorithmia, Datafoo, Kaggle. These are websites which basically sell algorithms. Now people know that they have data, people know that they've stored it, but then they have got two choices. One is develop the processing, develop the code around it themselves, or go ahead and buy it, which is a faster option. So these are the organizations which I've just listed them, a few of them over here. These are the organizations which basically are the ones which sell code, which you can kind of buy it, bring it into your environment, and then depending upon your requirement, depending upon your need, your situation, you can customize it. You can buy professionally, get the support for it, and then use it for your basically your analysis. So algorithm as a service model is also something which is going to pick up, and these are the companies. I've seen that these are the companies are springing up like anything. You can go and join there. You can create, as you can develop product as algorithms as product, and then these organizations can sell it and market it, and then the client and the customers can use it. So that is another aspect to it. There are actually lots and lots of them. I've just listed a few important ones, for your reference. Give me 1 second, guys. Yeah, a few important ones for your reference. Just 1 second. Yeah, just arranging my screen. What else? Fast and actionable data will be required. If you know a little bit about the data scientists and their job profile, you know that data scientists work in tools like R, in tools like Tableau, in tools like Pig and Hive, and their primary job responsibility is to continuously keep on mining the data and keep on looking the trends. Maybe sample the data, and then keep on looking for the trend, and keep on looking for the areas which are best suited for analysis, right? And then go to the business. Right, and that's how it works in any business analytics project, whether it's data warehousing, which also is a kind of business analytics area, or whether it's big data, the volume of data that we are talking about. And you'll always see that these guys would mine the data. They are going to come up with the areas. They're going to come up with these right set of questions these right set of questions which basically would be worthwhile analyzing and pursuing in terms of the technological exploration. So they'll say that, okay, maybe this is the product which we should concentrate upon, or this is the business strategy that we should concentrate upon. The business will take that up and give it to the technical team. Technical team will use this this setup of these this a gamut of technical implementation, analyze it quickly, and then come back to you and give you the clear picture of it. Fast and actionable data, more than big data, is something that is going to be the need of the hour, so that these data scientists can quickly analyze it, can quickly mine it, and quickly come up with these meaningful insights, rather than just storing everything. If and the organizations would be looking to store something which can be easily analyzed, which can be easily mined, which can easily give them a direction to move on, so that their time to market, their speed becomes faster. So these are the other two things that we can concentrate upon. And last but not the least, machine learning. Machine learning is also something which is going to pick up in a big way in next upcoming years. If you don't know what machine learning is, I'll just give you a couple of examples. I'm sure most of you will have your email IDs created, and most of you will have your emails created in Google email, which is Gmail, and you would see that from last a year or so, there are different categories which by default come in your email, right? So whether you and basically it categorizes your email as it comes. So whether it's your email is your main email, or your social, in the category of social area, or in the promotional area, or you can add labels of your own. So that is what is machine learning, where the system on its own decides what kind of an email is that, and then accordingly send it up to the relevant section, relevant label. And then over a period of time, as you keep telling that system that this is my main email, or this is my social email, or this is my promotional email, it keeps on learning more and more. So more and more feed that you give to it, the better that algorithm becomes. So that is one. It's basically called as classification type of machine learning. There are other types of machine learning areas as well. You've got something called as something called as group based. So you would have seen that in your Google News, right? Depending upon which category your news is, so if it is from technology, or the top story, or health, or business and finance, automatically Google keeps on segregating it based on what machine learning algorithm you have written. Spark, let me kind of give you a technical aspect to it. Spark, for example, has a machine learning library which you can using which you can use you can create your own algorithms for your own unique situations. And then basically over a period of time, as the more and more data comes, you can keep on customizing. It can keep on improving itself on the basis of the data, and on the basis of the actions that you take upon this data. So yeah, machine learning is another area which is going to be very sought after skill in the upcoming years. And as I said, the frameworks like Spark, frameworks like MongoDB, and frameworks like like Cassandra is something which is going to be very useful and instrumental in doing this kind of research. There are lots of other points. I can keep going on and on, but I think I should stop over here. I hope these 10 or 11 points that I have presented in front of you give you a bit of idea about where the industry is going as far as big data and its associated technologies are concerned. The future is bright. The future is great. If right now is the time that you are deciding to get into it, to kind of start learning the skill, this is the right time. On that note, I would just hand it over to Richard, hand it back to Richard, and we can take up the questions.
Excellent, Saeed. Uh, Great. I love the talk. Let's go ahead. I do have some great questions here. Before I start the questions, I'm going to go ahead and bring up a poll, and then they can answer the poll while we're doing a QA. And is everybody hearing me okay? I had a little feedback there for a second. Okay, so I'd say you definitely went over the number one questions. What's the job opportunities in Hadoop? I was going to just add on to that a little bit. If I was going to take, let's say, the most easiest route to get into Hadoop, what kind of training or certification would you suggest if it was like just an entry level?
Richard, I think that see Hadoop as a technology is something which is developed in Java. So the first and foremost thing is if an individual is preferably having some kind of Java background, it is very easy. It's relatively easier for him or her to pick up the technology. But nevertheless, the courses that the Simplilearn offers has a module called as Java for Java Essentials for Big Data, which is a very easy kind of easy to understand module, which within which even if the person does not have the Java background, can easily pick it up and take these courses. So the starting point would be Java as a programming language, and then doing a Big Data and Hadoop course. If the person does not have the Java background, you can, and if you have one programming background, at least one programming background, that then too it is fine. But at least one programming background, one programming knowledge, programming language background is definitely required to get up and going in this. Hopefully I was able to answer the question.
Oh, that was great. I have also another question here from P. Konar. I hope I'm saying that right. I guess it's Pulak. Mathematician who works with data science, looking for special courses and to get a job in the data industry. So he's already a professor in mathematics and wants to take that into the big data industry. What would be your suggestion for him?
Mathematician, statistics, by the way, I'm a statistics graduate, but I just kind of, thought it's worth mentioning. Mathematics and statistics is the best background to start, working in big data and its related technologies. The route to go for you, Konar, would be not through Hadoop, not through any programming language to start with. The better route for you to go would be through some kind of data scientist, data scientist software, data analysis software, I should say. So something like R, for example, R programming language. Doing a course in R programming language with some kind of statistical background is something which is going to be very, very useful for you. There are commercial softwares also available. So you've got something called as Tableau. I mean, to kind of sum it up, I would say that you already have a mathematics background. Give some flavor of statistics to it. Add to that a technological data scientist tool like R and Tableau. Do some course like that, which I'm sure Simplilearn definitely would have, and that is the way to go. Data scientist is your area, Konar.
Yeah. Excellent. I hope that thank you. I hope that answered that question on there. We have some other great questions. Let me just go back down here. I'm going to skip one until we're done with the poll because I wanted you to redo one of the slides. And then I have a question from Saranya. How do I become a big data trainer? How did you become a data, doing the educational side, Syed?
All right. So, okay, that's a very good question. Very close to my heart. First of all, trainer is something you can become when, first of all, you need to have a flair of speaking. You should like speaking. That's the very, basic minimum requirement. You should have the stamina for to keep speaking for a couple of hours, 3 hours, 4 hours, 5 hours at times. Secondly, you should have a very sound knowledge, the basic fundamental knowledge, because that goes without saying. People, come in these sessions where they want to understand the basic, they want to understand the fundamentals of the technology. And the third most important thing, which people look up at a lot, is how much practical experience you have. So being a trainer, you cannot have a unidimensional profile where you just remain a trainer. You keep, like what I keep doing. I keep doing a lot of consulting project. I keep traveling all across the world, keep meeting different clients, keep getting myself into different scenarios. And then whatever experience I get from these consulting project, I keep sharing it in my sessions. So I would say three things to sum it up. Flair for speaking, very solid core fundamental knowledge, and practical exposure. If you have these three things, you are up and running for it. Right, Richard?
Yes. Oh, that sounds great. I was so busy listening. I forgot that's supposed to be on the other end. We have some more questions coming. Let's see. We have Sandeep asking why Hadoop block size is more like 128 megabytes compared to other platforms. More technical side of it.
Sandeep, yeah, Sandeep, it's because data is so huge. As I was mentioning in the starting of very beginning of the presentation, I said that the game in big data starts at terabytes, 5 terabytes, 10 terabytes, and I usually go into in a lot more detail in my session, but what I would like to kind of give you an idea about is that the way HDFS stores data is in terms of blocks. When you save a big data file in HDFS, it divides that immediately into blocks of 128 MB of size by default, which by the way is also customizable. You can change it according to your requirement, but 128 MB is something which is kind of just about right. The other important aspect is that these programs, this analytical program that you write in Spark and in MapReduce, is something which works on these blocks. So if these blocks are too small, these programs would have nothing great to do. If these blocks are too huge, these programs will keep running forever. So at this point of time, with the state in terms of the volume that big data is, 128 MB is just about the optimal size. As I said, the future is where the data is going to go, is going to become huge. So it's pretty much sure that when the 3.x version comes in, this 128 MB will become 256 MB, and then the life goes on, the show goes on like that. So that's what the logic behind it, Richard and Sandeep. That's what my take on it on that.
Oh, nice. Thank you. I've got a question from, and I hope I say the name right, Subranjit has a couple questions. I am not familiar with Freher's guideline, but wondering about starting a career in analytics specific to Freher's guideline and aspects of Freher's in analytics as of now. What are the aspects for that as a career right now?
Sorry, Richard, can you say that again? I didn't get it.
It has to do with Freher's guideline or Fresher's guideline. I'm not sure what that is. Okay,
I
there
got
it is.
it.
I see a spelling error and then down below. Okay.
I got it. This is Subranjit, right?
Right, Subranjit.
Yeah. I tell you what, Subranjit, I keep telling this to all my, participants and attendees who come in my presentation. There are three things, basic that you require as a fresher to start your career in analytics right now. Number one, have a very solid programming background. Very solid programming background. C, C++, Python or Java. Definitely one of these, if both of them, nothing like it. So the first thing is have a very solid programming background, number one. Number two, you should have some big data technology course done. So Simplilearn, as I've been mentioning, as Richard have also been mentioning, Simplilearn has a wonderful course, big data and Hadoop course. One such course you should definitely do to get all the fundamentals and all the practical aspects of big data and Hadoop. So that's the second thing that you should do. And the third thing that you should do is that you should do one certification. Simplilearn has one, the course actually, culminates in doing certification, which is also very well recognized in the industry. So that is one thing. Another thing is that you should go for uh, a professional certification like Cloudera, for example. And my fourth option is related to that. The fourth guideline is related to that. See, what happens in Cloudera certification right now is that it's no more an MCQ question kind of thing. You will go there, they'll give you a couple of use cases, and then they'll give you a data set, and then they'll say that, okay, this is a data set, this is the environment, and then go ahead and implement these use cases on this environment and using this data set. So it's all hands-on. So what you should ideally do is that, as a fourth guideline, as a third guideline, you should definitely prepare for these certification and give them. That is going to boost your profile. And as a fourth guideline, what you should do is that you should have this kind of environment ready on your system. Wherein, I'll tell you about my system. My system has, Hadoop, Pig, Hive, Flume, Scoop, everything ready. And if I go and meet my consultants, I go and tell them that they give me scenarios. I tell them, okay, you give me a couple of hours, I'll go ahead and implement that for you. And almost 9 out of 10 times I end up getting the project. So have that environment running on your machine. Whenever you go for interview, go and meet your interviewer. Tell him the fundamentals which you anyway know, and ask him for use cases and implement it for him right then and there. There is no reason why anybody cannot hire you. These are the 4 things that I can suggest to you, my friend. Subranjit.
Excellent, right? Excellent. I think that also answered some of the other questions that were coming up. I'm going to go ahead and end the poll, and maybe you could, once I give you back the screen, there was a question on if you could, where was it, rerun one of the slides on the running the Hadoop.
I can definitely do that. Richard, do you want me to do that?
Yes, go ahead and do that, and then hopefully after that we'll have time for maybe 1 or 2 more questions, and then before we close the session.
Oh yeah, this is something that I love doing. Let me just show you a couple of commands quickly. So this is one of the HDFS commands, which basically gives you the view of HDFS. So there you are. I have run one program quickly over here. I didn't get into much of the details because the topic of the presentation was not really Hadoop. It's just kind of skim through it. But a couple of commands here. You can delete this folder by this command. Oh, I didn't mention about my blog also. So I'm going to mention about my blog as well. I write a blog where I write instructions about how to do all these installations. I'm just going to share it with you all. So basically, what this program does is that it runs a word count program from the from the software installation. So this is my Hadoop software installation. On my Mac. Let's go here, and this is one of the libraries in which all my examples are there. Right, and I'm using one of the files called as test.txt, and this is the output folder. So if I go here and say that Hadoop fs-cat and say test.txt, it is going to give me an output like this, which says that this is a demo session. Some words over there, and what happens is that when I'm going to run my program over here, it's basically going to analyze it, and it is going to find out the count of the number of the unique words over here. So this is one one MapReduce program which is running in front of you on a very small file. I usually run it on a big data file also, but it takes a while to run. So yeah, there you go. The program is running, up and fine. While this program is running, I'm just going to quickly pick up my my blog link and share it in front of you. Put it up in front of you and share the link also with all of you all. If I can do that, let me see. Where's the chat window to the entire audience? There you go. This is my blog link. It has the instructions to to install Hadoop, to run it. There are you can go through all these instructions and do installation of your own. Basically, when you do that installation, you end up getting this kind of output. Quickly, if I want to show you the output of how it looks like, I can say that fs-ls. In fact, let me say ls and say output. it's basically going to give me an output like this, which is just too cool. I'll say part dash r dash 1 2 3 4 5 and say cat over here, and is basically going to give me an output which says that you know what, you have entered demo 4 times and this 1 time and a 1 time and all. So basically, this is how Hadoop programs run. Right, Richard?
Excellent. I have fun playing with that too. I love watching the script go down there and then pulling up the answer. Um, we have, let's see, a couple time for maybe one or two more questions. One of them, and I can't find the original question, was what other systems are there that are outside of the Hadoop file system for big data? What's this competition look like?
The competition actually at this point of time is, with Hadoop, it's mainly with Spark. Who was that, Richard? Who was asking the question?
I'm looking for the original question. We've got a lot of good questions on here, and it was a ways back. But I think that was it,
Okay.
mainly open source. Is there any other open source? Because I know Spark can also run on its own. I think
Yeah.
MongoDB can do its own clusters, but it can also sit on the Hadoop file system, and there's a few others, or is those are the ones I
Yeah,
know
yeah,
of.
yeah. So yeah, definitely, yeah, and thanks for sharing that, Richard. Yeah, definitely. Spark is one, and Spark is a complete stack. Basically, it doesn't basically it requires Hadoop to run. It can run on its own, as you rightly said, Richard. Then you have there's one more thing which I was going to mention. Um, See, the thing at this point of time is that you have competition mainly in terms of the commercial softwares of Hadoop. So you've got Cloudera, you've got MapR, you've got Hortonworks, as I was suggesting, and the competition is really between these 3 or 4 major players. With Hadoop, technology per se, there are options available, which are basically, I would say, better frameworks. So analytical frameworks, like for example, you have got SAS, which is very good. But the problem with these, SAS, Teradata, the problem with these frameworks is that they are not open source. They come for a premium. The main reason why Hadoop as a technology and Spark as a technology is picking up big time is because their cost effectiveness. I mean, they virtually you don't have to spend anything in buying the software. So to answer your question, I would say that the options are really in terms of the commercial distributions. Plain raw Hadoop, I don't see there are any real competition coming up over there, apart from Spark, as you said, Richard.
Oh, excellent. I know Spark runs on the Hadoop file system quite well. I think one of the original people in Spark was one of the
Mhm.
developers in Hadoop. Is that right?
Sorry, Richard, say that again.
Oh, I believe one of the original developers of Spark, one of the main people behind it, and I can't think of names, it was also one of the main people behind setting up the Hadoop file system, and also goes all the way back to the Google file system that Hadoop evolved out of. Is that right?
Do you mean duck cutting?
Yes, yes.
Duck cutting, Mike Caffarella, these are the old guys. Duck cutting, by the way, Richard is working with Cloudera right now, and he's teaming up with one of the guys who's known as the father of the modern day data warehousing concept. I don't remember his name.
Parmander?
Rudyard sorry?
Was it Parmander?
No, his name starts with R. It's not striking me.
Oh,
Rudyard
Rupesh?
somebody. And
No, no, okay, not Rupesh. He's somebody completely different. All right. I just started to throw out our names. I'm getting in trouble now.
Yeah, it's actually not Richard Kimball. Yeah, Kimball. Yeah, it's actually Ralph Kimball. Ralph Kimball. Ralph Kimball. Yeah. Yeah. So he and Duck Cutting are together doing some crazy work in Cloudera at this point of time. Now, I keep following them, a lot. But
Yeah, I
anyways,
know.
hopefully I was able to answer the question, Richard.
Yes, oh, that was wonderful. Yes. I do believe we're at the end of the session. Let's go ahead and close the session now. I want to thank
Mhm.
everybody for being here. Greatly appreciate it. Happy learning to everybody. And there will be a, I can't remember, no, there's not a closed question after this one. It's the other one that has a closed questionnaire. And we
Mhm.
already did the quick questionnaire on this one.
Mhm.
Well,
Mhm.
thank you, Syed. I greatly appreciate it. It was a great session. I really enjoyed it.
Mhm. Thank you so much. It was my pleasure. And I was enjoying it so much that I felt like going on and on, but I have to stop somewhere, isn't it?
I understand.
Thank you so much, and thank you so much everyone else, and hope to see you guys soon in one of my sessions.
Excellent, and happy learning to everybody.
Thank you. Bye bye. Take care and have a good time. God bless. Bye bye.